All right, we're back with more review of a couple years ago stuff from Algebra 1 and Geometry. So we are going to discuss graphing linear equations a little bit again, but also the different forms of linear equations. So the two forms that you're familiar with at the moment are slope-intercept form, which is this guy, and standard form, which is this. Standard form is silly. No one really likes it. Excuse me, except for math teachers. Apparently I'm allergic to it. Okay, so we'll discuss this in the future in more depth, but in standard form, x and y, x and y have coefficients of a and b. A, b, and c all have to be integers. And then a has to be positive. So it's got a lot of rules as far as standard form goes. You have to be able to recognize what's a line and what's not. So when I look at these examples here, I notice you're a line and you're a standard form line. But here, if you solved for y, you divide both sides by x. And when you have x in the denominator like that, you create what's called a rational function. So that's not linear. This is also linear here, x equals 6 and y equals -5. Those are those specialty ones where one's vertical, this one's vertical here, and this one's horizontal. This next guy is a quadratic, so not a line. This is a square root function, not a line. This is a really funky looking line. This is a modified version of what we call standard form. We'll talk about that later. And then this guy here is an absolute value equation, definitely not a line. All right. So some information from your book. Remember that slope is change in y over change in x. The formula for slope is given to you here. You have to know this formula for your test. It's one of the questions is that you have to write it down. And then, of course, you have to use it. So those are those same formulas that they just came up with here. I want you to write these down on your notes. The definition of slope, a few different ways. We can say it's the change in y over the change in x. It's rise over run. Or you could go with the formula. y2 minus y1 over x2 minus x1. You can change the order of the subtraction. Just got to make sure you stay consistent. So y1 minus y2 over x1 minus x2, but make sure that the y is in the numerator and the x is in the denominator. All right, some examples of linear equations. Slope-intercept form, quick graphing form, we love it. Standard form, not super excited about it. Here's the thing. A has to be positive. I didn't mean to circle C there, sorry. So this first coefficient, this guy right here, has to be positive, and if it's not, you got to hit everybody by a negative to switch signs. A, B, and C cannot be fractions or decimals, they must be integers. And then this is a weird little modification of standard form, acceptable by, everybody. I just don't like it very much, so it's up to you which version you use, but I will be using this version. And then this guy in the middle. Some of you have very little experience with this, or maybe none, depends on who you had for a geometry teacher. This is called point-slope form, simply because if you have a point, which is x1 and y1, and you have slope, which is m, you can throw this information into point-slope form, and then you have a nice quick equation. So I'm going to skip some examples here. Let's look at this part of your notes. So this guy is currently in slope-intercept form. You don't need to go backwards and figure out what point-slope form is for that. That's not really anything we ever need to do. But as far as standard form goes, this is a far cry from standard form. First thing I'm going to do is collect the x and y both on the same side, and I'm going to choose to add this 4x over to the left side. And then a lot of kids think, oh, there you go, Brizzo, that's standard form. And I'm going to tell them, unfortunately not. Because 3.5, if you change it to a fraction, that's really 7 halves. And one of the rules about standard form is that you can't have fractions. So now we have to use that LCM technique where I hit everybody by a 2. And then we create an 8x plus a 2y equals 7. That is the standard form for that equation. All right, this next example here is currently in what we call point-slope form. So someone plugged in the information for the point and the slope. And I want to create slope-intercept form and then also standard form. I don't really care which order you go in, but generally speaking, you would go here next. So I'm going to distribute the 2. So we have y minus 6 equals 2x plus 6. And then if you were to add this 6 over here, you get y equals 2x plus 12. Oops, sorry. Okay. So we have slope-intercept form, and now we need standard form. I want x and y on the same side. And for most kids, what they would do is they would subtract the 2x over, which is okay. So they have negative 2x plus y equals 12. But the problem with this being standard form is that weird rule about the a value has to be positive. So everything here has to be hit by a -1 or divided by a -1 to switch signs. So standard form would be 2x minus y equals -12. I know that's a really weird rule about you can't have a negative coefficient for the x term, but whatever. All right, so here we have standard form. No need to go back to point slope form, but I would like you to come back and get slope intercept form. So in other words, we need to isolate the y. So first thing I would do is subtract the 4x. So we have negative 6y equals, I'd reverse the order here if I was you, negative 4x plus 7. And then divide everybody by a -6. Just watch your negatives when you're doing this work. Sometimes we get a little sloppy. Of course, everything has to be reduced. So coming back here to write my answer in slope-intercept form, y equals -4 over -6 is a positive 2/3 when you reduce x. And then -7/6 would be a -7/6. Decimals would not be acceptable there because you'd be truncating and rounding, which is not exact. So make sure they're looking good. All right, we have a slope-intercept form of a line. They want us to do a few things. First, they want us to graph it, and then identify some things because of the equation. So I'm actually, I'm probably going to, well, I guess we could graph it first. So since it's in slope-intercept form, we would start on the y-axis at -5. Whoops, let's pretend it's right there. And then our slope, remember our slope is rise over run, so it's 2 over 1. So I'd travel positive up to right 1. And then I'd totally graph it beautifully like that, right? It's actually not bad. So when they say, what is your slope? Our slope is 2, or you could even write it as 2 over 1. Our x-intercept is a little difficult for me to find based on my graph because, frankly, I didn't graph very well. I could estimate it, and if I actually had graph paper, I'd probably do a really good job. But since I can't see the x-intercept exactly, what I'm going to do is I'm going to calculate the x-intercept because I know at the x-intercept, the y value is 0. So I'm going to go back to our equation, and I'm going to substitute in a 0 for the y. So instead of y equals 2x minus 5, I'm going to say 0 equals 2x minus 5, and then I'm going to solve that. So adding 5 and then dividing by 2, you can either say it's at 5/2 or 2.5, and that's our x-intercept. I'm going to say 2.5. I'll be honest, I would have not guessed 2.5 off my picture. Eh. And the y-intercept was really obvious because it was in that form. The y-intercept is at 0, -5. You could have gone back and plugged in a 0 for the y, or sorry, excuse me, a 0 for the x, and said y equals 2 times 0 minus 5, and guess what you get, guys? You get y equals -5. So up to you. I just need the answers. Here we have a line that is not in the quick graphing form, but we still could graph it really quickly. The point that they used in this equation here, remember it's y minus y1, so that tells me that the y value is 1, and then it's slope times x minus x1. So in this parenthesis set here, it's really x minus a -2. It's that weird opposite rule thing that I always tell you in algebra. There's a built-in negative, so that's the x coordinate. So the ordered pair that they used here is -2, 1. And then the slope is clearly a 1/2. That's the number in front here. So when I go to graph, you don't have to start on the y-axis. If you have a point on the line, you can just start there. So I'm going to start at -2, 1. So I'm going to start right here. And then I'm going to graph a slope of 1/2. Not very well, though. All right, so 1, up 1, over 2. And totally nailed it, right? Totally. Okay. You could have done some rearranging. There would have been nothing wrong with that, you know? All right, let's talk about slope. I already know it. Slope is 1/2. X-intercept is going to be a little tricky for me to visualize. I mean, I could guess, but, you know, it's not going to work out well for me. So what I'm going to do is I'm going to plug in a 0 for my y. So in my original equation, which you can't see, I'm going to plug in a y equals 0. So 0 minus 1 equals 1/2 times x plus 2. So I'm going to move my work up here. So I have -1 equals 1/2 times x plus 2. I'm going to go ahead and multiply this and this by 2. I don't like that 1/2. I don't like dividing by halves, sorry. Alright, so you get -2 equals x plus 2. And then subtracting 2 from both sides, and we get x equals -4. So that is our x-intercept, -4. I may have guessed that. Here's the trick, guys. If you want to not have to guess real hard, then just graph really nicely and graph on graph paper. Alright, so same idea for the y-intercept. The x value I know is going to be 0. So I'm going to go back to my equation that I have from the original part. I'm going to say y minus 1 equals 1/2, and then 0 plus 2. So 1/2 times 2 is 1. So I have y minus 1 equals 1, and y equals 2. Alright, lovely. There's many other ways that we could have found those. We could have rearranged the form to standard form and found them that way. Standard form, the only thing it's really good for is finding the x and y intercepts. So let's keep that in mind here. I'm actually going to find those first. So where it says x-intercept, remember that means that your y value is 0. So if you go up to the standard form equation and you plug in a 0, this whole term is going to knock out and you get 2x equals 12. So you get x equals 6 for your x-intercept. And then similarly, for the y-intercept, that's where you're going to substitute in a 0 for the x. So if I go back up here, and this is a 0, so it's no longer there, and I get -3y equals 12, so y equals -4. When it comes to graphing, I'm just going to use those to graph. So 1, 2, 3, 4, 5, 6 is my x-intercept. Down 1, 2, 3, 4 is my y-intercept. And you can actually calculate slope based on those points. It might not be, it might not be well done as far as graphing goes. Whoopsies, obviously. But we know that slope is the change in y over change in x, so the rise over the run. So from here to here, it goes up 4 units and right 6 units, which of course reduces to positive 2/3. Would have found that same slope had I rearranged the original equation into slope-intercept form by isolating the y. So it's really up to you. You have to be kind of flexible in this part of math because there's not just one way to get things right, so we got to be careful. All right, on the back of that worksheet, so we're looking at worksheet 2b. We're filling in some blanks here. A function is linear if it can be written in the form y equals mx plus b, or ax plus by equals c. Point slope form is y minus y1 equals m times x minus x1. The slope, I'm assuming they want there, yep, the slope of a non-vertical line through these ordered pairs is found by using this formula, which you have to know. We say a vertical line has undefined slope, and I would like you just to kind of scribble this out because it starts to get confusing when kids start to say things like no solution symbol, like 0 with a line through it. So just when it's vertical, tell me it's undefined. And then vertical lines have an equation like this. So it'd be like x equals some constant. Horizontal lines have, okay, so here you can either say no slope or you can say 0 slope. I prefer 0. And the equation for a horizontal line is y equals some constant. You have to know those. Those must be in your memory bank somewhere. They're great for test prep, getting ready for your SAT test. The horizontal line through the ordered pair 2, -4 has the equation. Okay, so here's the clue. If it's a horizontal line, then it has to be in the form y equals something. So if you think about this ordered pair, 2, -4, please don't confuse slope with ordered pairs now, guys. This is what happens in algebra. We get a little one-track mind. So if I have a horizontal line going right there, through that point, well, this has to be the horizontal line at y equals -4. And I think if I thought about that a little harder, I didn't even have to draw it out, because remember, this is the x-coordinate and this is the y-coordinate. So when it's a horizontal line, which is in the form y equals something, just look at your ordered pair and you'll know what y is. So in this case, y equals -4. However, if I ask you now for a vertical line through that same point, we're going to have a different equation, because vertical lines, I know, are in the form x equals something. So when I look at my equation, the x is 2. So I don't have to give you a ton of clues in order to find the equation of a line. Keep that in mind. All right, blast from the past. Parallel and perpendicular lines. I'm sure you guys all remember that. Something to do with their slopes, right? If two lines are parallel, their slope is equal. Because they have the same rate of change, therefore they will not intersect. If two lines are perpendicular, their slopes are, this is the tricky one, they are opposites, meaning opposite signs, and reciprocals. So positive versus a negative. And then a reciprocal, meaning the opposite fraction. So you would flip the fraction. You have to be kind of tricky with like 2/3 is easy for perpendicular. That would be -3/2. Opposite sign, but you flip the fraction. But if you have like -4, the opposite reciprocal to that would be a positive, 1/4. And then 0 is the one that always tricks kids. The opposite reciprocal to 0 is not a number, it's undefined. That's the horizontal vertical line thing, so it gets a little tricky when you have a 0 or undefined. Alright, so here is a clue. We have a line, 1/4 x minus 6, and my line is perpendicular to that one. So if his slope is 1/4, perpendicular to that would be a -4/1 or -4. A parallel line would have the same slope, so that would be positive 1/4. All right, which describes the relationship between EF and GH. This is really a geometry question. You probably did a bunch of these in Geo. I need to figure out the slopes in order to determine that. So if they have the same slope, they are either parallel lines or they happen to be the same line. So we have to be kind of careful about that. So let's find the slope between EF. So slope would be change in y over change in x. So I'm going to do 6 minus 3 over -4 minus, careful, -9. Usually when mistakes happen here, it's this double negative issue. So 6 minus 3 is, let's see, that's 3 over, that becomes a plus, 3 over 5. And then for GH, let's see here, -1 minus -6 over 11 minus 8. So plus here, so let's see, that's a 5 over 3. Right? Did I miss a sign anywhere? Okay. So here's what I'm seeing. I'm saying this has a slope of 3/5 and this has a slope of 5/3. They are reciprocals of each other, but they are not opposite reciprocals. So they are not perpendicular, they're not parallel. They can't be the same line if they're not parallel. So therefore these are neither. A little bit of a trick question there. All right, so here they want me to do a few things. They want me to graph 1/2 x plus 4. So it's in that quick graphing method. I'm going to start at the y-intercept of 4. And then a slope of 1/2, so up 1, right 2. Could also move down 1 and left 2. That was pretty good. Now I want to find the equation of the perpendicular line to that. So here is the point it's going to go through. And this clue about it being perpendicular to this line, that's a way of them telling me slope. So if the original slope is 1/2, the perpendicular slope to that would be -2/1. So here we have a slope and we have a point. So as far as finding the equation, depending on who your geometry teacher was, you might have been taught 2 different ways to do this. I like to use point-slope form because I think it's marvelous. So you can plug everything you know into point-slope form. For instance, you know that the slope is -2. And you know that your coordinate point is right here, -2, -3. So that's the x1, and that's the y1. So I just go ahead and plug everything in. Y minus the y coordinate equals slope times x minus the x coordinate. Now you do have to do a little bit of cleaning here. So we got y minus 3 equals -2 times x plus 2. And it doesn't say what form they want the equation in. So this is technically an okay answer, but sometimes I get tricky and I ask you for other forms, right? So are you flexible enough to go to the other forms? I don't know, let's see. So next thing I would do if I want point slope form, for instance, I could distribute the -2. And then I'd add the 3 over. So y equals -2x minus 1. Or, if I got really fancy, what if I said I wanted standard form? So let's take this form, let's add the 2x over. Oops, we're having some technical difficulties here, so hopefully this hangs on. 2x plus y equals -1. So point slope, slope intercept, standard form. You can give me all the forms. If you can do that for me, you'll be in good shape. Alright, so we're back. Let's see. This is, I believe, on the notes. Yep. Slope of 1/3 goes through the point 3, -4. So again, I'm going to use that new favorite point slope form of mine, which is y minus the y coordinate equals slope times x minus the x coordinate. So y minus the y coordinate equals slope and then x minus the x coordinate. Again, it doesn't say what form they want it in. I would expect you to change this double negative to a plus though. So y plus 4 equals 1/3 times x minus 3. So if I wasn't particular about the form, I'm okay with that answer. However, I think I do get a little tricky here. So what if I wanted slope-intercept form? I'd distribute the 1/3 and I'd get y plus 4 equals 1/3 x minus 1. And then I would subtract the 4 over. So that's slope-intercept form, which is great. What if I got really weird and I said I wanted standard form? So first thing I'd have to do for standard form is I'd have to take this equation, and I can't have fractions. So that's the first thing I usually take care of, is if there's a fraction, I get rid of it. So what if I hit everything by a 3? That would produce 3y equals 1x minus 15. And then remember, for standard form, you're supposed to leave this as a positive. So you can leave it where it's at and move everybody else around, or you could subtract the x and then divide everything by a -1. It doesn't matter. So most of you would subtract the x over. And then hopefully you remember that this is not good enough. You have to have a positive coefficient here on the x. So if I divide or multiply everything by a -1, I get x minus 3y equals positive 15. So point slope, slope intercept, standard form. You have to be able to go fluidly between all of them. All right, let's see what else we have here. Oh, this one's fun. So through these 2 points, so I don't have slope yet, I gotta find it, and then I have to find the equation. For this one, because of the sake of time, I'm just going to leave it in point slope form when I'm done. But the issue is I don't have slope. So first task, find slope. y2 minus y1 over x2 minus x1. So that's what? -15 over -6. Please reduce that to a -5 over, no, positive 5 over 2. Hello. Did I do that right? Yeah. So there's our slope. And then when it comes to choosing a point, you can use any point you want. Well, I don't really like negative, so I'm going to choose this positive point here. So the equation for point slope form is y minus the y coordinate. So since I'm using this point, y minus the y coordinate equals the slope, and then x minus the x coordinate. So remember, there's ways we can manipulate this and other equations we can come up with, but because it didn't say what form, for the sake of my time and your time, we're just going to move on. Oh, this one's fun. They tell me it goes through this point. That's an awesome point, and it's perpendicular to this. So his slope is 2/3. The perpendicular slope to that would be -3/2. And we can do point slope form if you'd like, but this is a very special point. Anytime the x value is 0, this is the y-intercept. So since I have a slope and a y-intercept, I'm actually going to jump straight into slope-intercept form. You don't have to do it this way. Oops, I do need an x though, plus 3. So I had the slope and I had the y-intercept, so I went ahead and threw it into that form. Again, it depends on what your goal is. If your teacher was a jerk and wanted you to have it in standard form, then you'd have more work to do. But you know what? I'm not a jerk today. Okay, this next one. We are going to be parallel to this line. Okay, this is a bit of a bummer because parallel means I have the same slope, but I don't actually see slope because it's not manipulated in a form where I can see the slope. There is a formula for finding slope. It's really not that hard, and maybe you've come up with it on your own, but for most kids, they just want to rearrange this. So if we subtracted the 4x and then divided by the -1, this guy's slope is +4. And since we're parallel to that, we also have a slope of +4. And I go through this point. So if you don't mind, I'm just going to leave it in point slope form. So y minus the y coordinate, so y plus -8, y minus -8 would be y plus 8, equals slope we just found, and then x minus the x coordinate. Again, there's other ways to find equations. I know some of the geo teachers don't teach this equation, and they just have you plug in x and y and slope into slope-intercept form and then find b that way. I don't really care, guys. I just want you to get it right and be able to show me the work. Oh man, this is a challenging question. How fun. Perpendicular bisector. So what that means is, if I found the midpoint between here, that would be an ordered pair that the line would go through, because bisect means to cut through the midpoint. And then if I found slope of that segment and then found the perpendicular slope, I'd have a point and a slope. So basically I'm going to be using these two clues to find the equation of my perpendicular bisector. Alright, here goes. Midpoint. Remember the midpoint formula is averaging the x's and averaging the y's. So 2 plus 0 cut in half, and then 6 plus -8 cut in half. So my midpoint is, let's see, 2 divided by 2 is 1, and that's -2 divided by 2, -1. Okay. The slope is y2 minus y1 over x2 minus x1. So that's -14 over -2, so that's a 7. And if I'm perpendicular to that, my slope is -1/7. Whew, fun times. Okay, perpendicular bisector equation. Use this point, use this slope, and leave it in point slope form. So y minus the y coordinate will actually be y plus 1 equals -1/7, and then x minus the x coordinate. Woo-hoo-hoo. All right, it was a fun trip down memory lane for everyone, wasn't it? All right, so you have a whole bunch of review worksheet practice problems. I think we only assign the odds. We're trying really hard to cut back on your workload because we want to respect your time, Mrs. Hoffbauer and I. Best wishes. Please do come in and don't let this lesson scare you because this is actually just review, but I know it's been a few years. So if you need to come in for some help, that's totally fine. Your first summative is going to cover all this old material plus a couple other things we're going to talk about over the next few days.